This lesson is about the volume and surface area of solids. We first look at the different types of pyramids. A pyramid is named according to its base. So the pyramids below are right pyramids, as the apex, which is the sharp point, is directly above the center of the base. This is a triangular pyramid because we have the triangle as the base. And this is a square pyramid, pentagonal pyramid, and rectangular pyramid. Now we will look at the parts of a pyramid. The sharp corners are called vertices. The vertex at the top is called the apex. And the slant height is the height of a triangular surface. Then we have the slant edge. And the height of the pyramid, as mentioned earlier on, is directly above the center of the base. The triangular surface is also called a lateral face. It is important to identify the right-angled triangles in a pyramid. The most important triangle is the right-angled triangle that is formed from the height, half of the base, and the height of the triangular surface. The second right-angled triangle is formed from the height of the triangular surface with the edge of the pyramid. And finally, we have a triangle, a right-angled triangle that is formed with the height of the pyramid and the slant edge. Now let us take a look at how we find the volume of a pyramid. The experiment shows us that the volume of a pyramid is 1/3 of a prism, and this is 1/3 base area times the height. And it is the same for the cone as well. Now, so we can find the volume of a pyramid by taking 1/3 the base area times the height. In this case here, the base is a square, so we have 1/3 the base area, which is 5 times 5, times the height, and this works out to be 50 cm cube. Next, we have a rectangular pyramid, and once again, to find the volume is 1/3 the base area, which in this case is 7 times 5, multiplied by the height 6, and this works out to be 70 cm cube. Now we will look at the surface area of a pyramid. When you open up a pyramid, you have 4 triangles and a base. For the square pyramids, the triangles are all the same size. Whereas for a rectangular pyramid, the 2 opposite triangles are the same. So there are 2 sets of triangles. Let us now calculate the surface area of this pyramid. Now the first thing to do is to find the height of the triangular surface, which forms a right angle triangle with the height of the triangle of the pyramid. This height here is the height of the triangular face, and the base here is 6. Right. So using Pythagoras theorem, we have x squared equals half of the base, which is 3 square, plus the height of the pyramid, 4 square. And x works out to be 5. So to find the total surface area, we have 4 triangles, half base times height, and height is x. Plus the base, which is 6 times 6. And this works out to be 90. This is 4 times 2 is 30. 30 plus 36 is 96 cm squared. We'll now look at the surface area of a rectangular pyramid. As mentioned earlier on, there are two pairs of triangles with different height. So we call one of them X and the other one Y. And these heights are formed with the height of the pyramid. Let us find X first. So x squared using Pythagoras theorem equals to half the base of the rectangle, which is 3, plus the height of the pyramid, which is 4, and x works out to be 5. Next we find y. So y squared, the hypotenuse, equals to the half the base, which is 2 square, plus the height of the pyramid, which is 4 square, and y works out to be 4.4721. Now we have to give to 5 significant figure because we want to make use of it later. Alright, so now we want the total surface area. Which is actually two triangles of half base times height. Another two half base times height, and plus the base, which is 24, 4 times 6. And this works out to be 70.8 cm squared. Let us look at a further example. In this case here, we need to find the height of the pyramid. For this kind of sum, we always begin with the formula for the pyramid, with the values substituted in. What we are given is the volume, and we know the volume is 1/3 base area times the height equals to 28. This is how we begin with the formula. It works out to be h is 7 cm. Now, in the earlier experiment, we see that the volume of the cone is 1/3 base area times height. So here we are calculating using the formula 1/3. Now, the base area here is a circle. So the circle is of area pi r squared multiplied by the height. And this works out to be 37.7 cm cubed. Now let us take a look at the surface area of a cone. A cone opens up to be a sector with a circular base. the curved surface of the cone opens up to a sector, and the radius of the sector is actually the slant height, and the circumference of the base is the arc of the sector. A sector is simply a fraction of a circle. To find the surface area, we have the base, which is pi r square, and the sector area is a formula pi r times L. So again, we need to find the slant height using Pythagoras theorem. L square is 3 square plus 4 square, and L here is 5. So now the total surface area is pi RL, which is pi, R is 3, and L is 5, plus the base, pi 3 squared. Now, it is good to work everything in pi first. 15 pi plus 9 pi, which is 24 pi. So when there's only a single pi, then we use the calculator to get our answer, 75.4 cm squared. Now let us take a look at the volume of a solid sphere and a hemisphere. Using a similar experiment as shown earlier on, we can confirm that the volume of a sphere is 4/3 pi r cubed. This formula only depends on the radius to find the volume. So once we have the radius, we can work out the volume, which is 4/3 pi r cubed. Works out to be 113 cm cubed. The hemisphere is actually half a sphere, and therefore is half of 4/3 pi r cubed, which is actually 2/3 pi r cubed. And this is actually half what we have calculated, 56.5 cm cubed. Now let us take a look at the surface area of a solid sphere. Now it can be proven in an experiment, right, by taking a rope going round the sphere and then using the rope to form a circle. We find that the surface area is actually 4 times the area of a circle with the same radius. So it's 4 pi r squared, 4 times pi times 3 squared. And that gives us 113 cm squared. If we have a hemisphere, then we have to consider the base, pi r squared. So this one is half of 4 pi r squared. Right, so half of 4 pi r squared plus the base pi r squared. This actually works out to be 3 pi r squared, which is 3 pi r squared, and that is 84.8 cm squared. In this topic, we are also concerned with the volume and surface area of combined solids. So using the different formulas to find the total volume, we have the volume of the cone, which is 1/3 pi r square times height, and the volume of a cylinder is pi r square times the height. So here we cancel. We have 12 pi here, and here is 9 times 1, 45 pi. So altogether we have 57 pi, which works out to be 179 cm cube. For the total surface area, remember our formula. That is, the curved surface is pi r L. The curved surface of a cylinder is 2 pi r h, and the base is pi r squared. Right? So now this is pi r L. So again, we need to find the L. So L square is 3 square plus 4 square, and L is actually 5. Okay, so pi r L, we have pi r L plus 2 pi r h plus pi r square. So once again, work out everything. 15 pi plus 30 pi plus 9 pi. Okay, so we have 30, 45, 45, and 54 pi, which gives us 170 cm squared. Now let's take a look at another use of the formula. In this case here is the transfer of volume, when one volume becomes another. So they should have the same volume because one is made from the other. Therefore, to solve this kind of sum, we just equate their volume. The volume 1 is the volume of the cone. So since here we have 2/3 times pi r cubed for a hemisphere, and for the cone we have 1/3 pi r square times the height. Okay. So here we can cancel, and pi is cancelled away as well. So we have r cubed equals to 18, and that gives us r is 4.24 cm. Now we move on to the last example, which again is the transfer of volume. This time round we have a solid pyramid that is completely submerged in a rectangular tank filled with water. Now the pyramid will occupy space in the water, which pushes up an identical volume of water. Right? So the volume of the water is the same as the volume of the pyramid, volume of water that has risen. Okay, so that is where again we equate this volume. We call this volume 1. This volume 1 is equal to the volume of the pyramid, which is 60. Okay, the volume of the water that has risen is length times breadth times height, equals to 60. That gives us the height is 2 cm high. And this is the end of the lesson for volume and surface area. Thank you.